Lesson 84, Algebraic Terms. So here are some examples of algebraic terms. Basically, they have variables in them. So here's a term, 3x squared. And here's a term, negative 2x. Here's a term, positive 4y plus 9. So these are all considered algebraic terms. Notice that the 9 doesn't have a variable on it. Evidently, that's okay. It's just considered a term. So algebraic terms are separated by or from one another by plus and minus signs. Polynomials are algebraic expressions that contain more than one term. So, for example, x squared plus 7x plus 3. So if you look at this, this has 3 terms. Can you see the 3 terms? Here's an x squared plus 7x plus 3. Those are your 3 terms. So we have names for some polynomials. For example, a monomial. Mono usually means 1. So the number of terms in a monomial is 1. There's 1 term. And here's an example of a monomial, 2x, or 3. As an example, z to the 5th power. This is an example. These are 3 examples of monomials. Now we have binomial. They have 2 terms. Bi, if you remember, like bicycle has two wheels. Binomial, bipedal, that's something that walks on 2 legs or 2 feet. Binomial has 2 terms. So here's an example of a binomial, 3 minus x. Here's another one, y minus w. So there's 2 terms in this polynomial, and we call it specifically a binomial. Then we have what's called a trinomial. I bet you can guess how many terms that has. 3. And here's an example, x squared minus 2x plus 4. That's called a trinomial. Then if you have anything greater than 3, we just call it a polynomial. So all of these are polynomials. We just have specific names for the 1, 2, and 3 number of terms. A constant is just a term with no variable. It's just a number. So for example, number 4, that's a constant. Like negative 5, pi. These are constants. And I like to think of the word constant. I kind of compare it to, I say, well, it constantly has this value. So every time you see the number 4, it means 4. Like, you know, when you see the letter X, sometimes it means 4, sometimes it means 2, sometimes it means a half. Like, variables can vary in what they represent. Constants are just constantly the same. So they're just numbers. It has no variable. So when you have a variable like z, that means 1 times z. Or if you have a negative a, that means a negative 1 times a. So if a term does not have a number in front of it, then the number in front of it, we call that a coefficient, is the number 1. So we're going to write that down. If a term doesn't have a number in front of it, in parentheses, will you put coefficient? Because that's what we call the number in front of a variable. The number in front of it is a 1. So if it's a plus z, then we have 1z. If it's a minus a, we have basically negative 1a. Now we're going to get to our cows and pigs and candy bars and stuff. These are called like terms. Like terms are terms that have the exact same variables. So here's some examples of like terms. 2x squared would be a like term with negative 6x squared, which is also a like term with just plain x squared, and that's a like term with 10x squared. So if you notice, every single one of these has an x squared. So these are considered like terms. Here's another example. 3m, 6m, those are like terms. Now we're going to do some examples where I'm going to ask you, are these like terms? Yes or no? But I'm going to turn the page to do it because I ran out of room. So I'm starting on my next page. Give you 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Are these like terms? This is kind of an eyeball exercise because you have to look at each term and see if it has the exact same variable. 3x and 2x. Are these like terms? Yes or no?
Yes.
Yes. Can you see they both have an x? Are these like terms? 3a and 5b?
No.
No. Okay. How about 7x y squared, 13x y squared, and negative 4y squared x?
Yes.
Are these like terms?
Yes.
Yes.
Yep.
They are. So notice that the order is different, but in multiplication we have what's called commutative property, and order doesn't matter. So you can always just switch those and say, oh, well, yeah, that's an xy squared, same as these. How about this one? 5ab squared and negative 4a squared b.
Yes. No.
This is a tricky one. These are not like terms. Notice that this has two b's here, a, b, b. This one has two a's and only one b, a, b. So even with the exponent, you got to double check that the exponents are the same on the variables that you're given. So these are not like terms. Now you are going to be asked to combine like terms. So once you find the like terms, then we have to combine them. So this is like the example we did before the notes, where we had 5 cows and 2 pigs, and then we had to combine the cows that were coming, and we had to take away the pigs that we owed. So we want to combine like terms. So here is our polynomial. 7x plus 2x plus 4x equals. Now if you just plug in something that you recognize for x, like cows. You have 7 cows, you're going to add 2 cows, you're going to add 4 cows. Can you see how that would give you 13 cows, right? No? Did I add it wrong?
Is X a count?
Yes.
15 cows.
It's 13.
13 cows. But the X was cows, so we just write X. We don't write cows. We just use that word to kind of help us see. You can only add or subtract like terms. So if it does not have another term like it, you can't add it. You just have to write it down again. I'll give you an example. Notice that when you're adding the cows, they don't change to like cows squared or cows cubed, right? They just stay. You have 7 of them, you add 2 more, you add 4 more, you have 13 of them total, okay? So the variables stay the same. It's only the coefficients that change. So here's an example. 3x plus 3 minus 1 minus 5x. Now when I see a minus sign, I think of owing, like how we owed some pigs. So I use the word owe in front of it. I separate my terms. Remember that the sign in front of it is part of the term. So I like to kind of separate them, draw a line right after the number part so that they have the sign with them. I have a 3x and a negative 5x. So we'll use the word like Tootsie Roll or something. We have 3 Tootsie Rolls and we owe 5 Tootsie Rolls. So what do we have? Negative 2 Tootsie Rolls. So instead of writing Tootsie Rolls out, we'll just put an x, negative 2x. And then we have a 3 minus 1. It's just 2. And is it plus or minus? Plus 2. So when you have number parts, you don't have to add another word like sucker or cow or pigs or whatever. So this simplifies to negative 2 plus 2. We just took our terms, the ones that were alike. Remember, like terms just have the exact same variables. Add the like terms together. The constants, we can add the constants together. If there was another something over here, like if there was like a plus x squared, it doesn't have a like term, so we would just add it here. In fact, let's just do that. If we had a plus x squared, notice that there's no other x squared, so we just rewrite it the way it is. That's the end of the lesson.